So now let's discuss equations. As I mentioned previously, there's an x equals equation and a y equals equation for parametric, right? You're going to have two equations that both depend on one parameter, which is t for time. So the horizontal displacement of this ball from the scenario that we're talking about is depending on time. How far the ball goes depends on how long it's been in the air, right? And vertically speaking, the same is true as well. How high the ball is depends again on time. So both horizontally and vertically, this ball depends on time. So let's look. Instead, again, we're going to make x a linear function. Our slope is going to be the velocity. And v sub 0 means the initial velocity times time. So this is like your mx plus, we're going to say d sub 0, which is the initial distance at which the ball was, where the ball was. So its initial horizontal distance. And then with y, we're going to use a quadratic function. And this quadratic function is going to be negative 4.9 t squared. So this is like ax squared, where negative 4.9 is your a value. Plus, again, you're going to look at your initial velocity. And I should really put v sub 0 y, because this is your initial velocity in the y direction, which is different from your initial velocity in your x direction. All right, multiplied by your time. So this looks like bx, your linear looking term. Plus, we usually say c, or the y-intercept. This is, in other words, is what was the initial height, right? Because everything right here is vertical, while the x1 is horizontal, all right? So really the rest of this problem is just finding out these missing coefficients. You know, what is v sub 0x? What is d sub 0? What is v sub 0y? And what is h sub 0? Okay, so that is what we are going to try to figure out. All right, so if we move along, the horizontal calculations aren't bad at all. All right, so we said x equals, and we're going to go with our v sub 0, our initial horizontal velocity multiplied by time, plus the initial distance horizontally away from the goal, counting the goal as 0, 0. All right, so we're going to say, well, we know how far away the ball was from the goal. It was 20 meters away from the goal, so that is given. Now the only thing that remains is to find out how fast is the ball going. Well, in order to find, how fast something is going, you're basically going to take the distance that it travels. In other words, how far did this ball go? Well, if it went from 20 meters away from the goal all the way to 20 meters away from 120, that would be to 100. Then we'd find really a distance of 80. So it traveled 80 meters. And then how long did it take? Well, it took 3.6 seconds. So if I take 80 and divide it by 3.6, I get 22.22. In other words, the horizontal displacement of this ball is 22.22 meters per second. So multiplied by time plus 20. What that basically means is if I want to find how far down the field the ball is, horizontally speaking, this is not going to help me with how high the ball went. But if I want to find how far the ball has gone, all I need to do is substitute a time. So here's an example. All right, to find the horizontal location after, for example, let's say 3 seconds. All right, let's say 3 seconds. Okay, and you know what? Let's make this a little more simple. And we're going to go with, let's just go with 1 second. All right, after 1 second. All right, so after 1 second, well, 22.22 times 1 is 22.22. Add 20, and you get 42.2 meters is how far the ball has traveled. So the ball is going to travel 22 meters every second. So that's constant. Then you just add your initial distance from the goal, which was 20. So in other words, after 1 second, this ball is 42 meters away from the goal. After 2 seconds, you're just going to add another 22.2. After 3 seconds, you add another 22.2. So that's how simple this horizontal displacement works. All right. You are using a linear function. The only thing that we did right here is we have to solve for the slope. In other words, we have to solve for the velocity of this ball, horizontally speaking, which again, that horizontal velocity is not going to change throughout the trajectory of the ball.